Root variations. Graph the root function below on the set of axes. It will be helpful to make a table, or just use your graphing calculator's table function. State the domain and range for each function. Alright, so just to remind you, I'm not going to use my calculator because I think it's good practice to just do it by hand. But for those of you watching at home, you can go to y equals radical x minus 1. And it's very important that that minus 1 comes outside the parentheses. If your calculator doesn't actually make the whole square root, you have to close the parentheses after the radical is finished. To get the table, we press second graph. All right, and I can see that, if I go to any of these negative numbers here, I get an error because they're not real answers. So I have to start at 0. And then really, if you're going to graph it, it's much easier to use the whole numbers than the irrational numbers. All right, but I'm going to do this real quick by hand. I'm going to make a sideways table. Oh, that's not right. Okay, so I know the first value I could possibly plug in for x is 0, because any negative number won't give me a real answer. I can plug in 1, and then I'm going to just plug in perfect squares here, because I don't want to write down a whole decimal. It's way easier just to write down a whole number. So the square root of 0 is 0, minus 1 is negative 1. Square root of 1 is 1, minus 1 is 0. Square root of 4 is 2, 2 minus 1 is 1. Square root of 9 is 3, 3 minus 1 is 2. So I'm just going to plot these points. And this will continue all the way to infinity in that direction. All right, graph the function y equals negative root x plus 3. So when I'm putting this one in, it's going to look a little bit different. I'm going to put the negative sign in front, then the square root, then x plus 3 in my calculator. Oh, I made an error. Oh, yeah, I just made a huge error that I tell you guys not to do all the time. All right, that's actually not, I put the minus sign there. So make sure you put the negative button down here. That's what you want to press instead. So that should give me no problem when graphing this. All right, and we can see now, because it's negative, that we're getting like the other side of that parabola if I turn my calculator sideways. But I'm going to do the same thing. All right, so if we remember from the previous part, when I talked about the domain, right, whatever's in that radical here has to be greater than or equal to 0, because if it's less than 0, then we'll be taking the square root of a negative number. So here, I know that x plus 3 has to be greater than or equal to 0. 0 is the lowest number it can be. So that means for my possible values of x, if I wanted to just isolate x, I'd subtract 3 from both sides. Now we get x has to be greater than or equal to negative 3. So that tells me that negative 3 is my lowest input here. So I'm going to plot that one first, right? Negative 3, when I plug that in, negative 3 plus 3 is 0. Square root of 0 is 0. Can't make 0 negative, it's just 0. So that's our first point. Negative 3 comma 0. All right. Now when I plug the next number in, I could do negative 2 here, and I will. I'll do negative 2 next. Negative 2 plus 3 is positive 1. Square root of positive 1 is 1. And I'm going to put that negative sign in front now. All right. And, just to show you what I'm doing, I really should be showing this work instead of saying it out loud. But just to show you what happens when I plug negative 2 in. That's equal to negative square root of 1. That's just equal to negative 1. All right. So negative 2 and negative 1 is my y. And as you can see, we are starting to form that parabola shape. Okay. Next point I'm going to plug in. I'm not going to plug negative 1 in, because when I plug negative 1 in, I just get positive 2. I don't want to take the square root of positive 2 because it's an irrational number. So the next, I've already the square root of 1. My next number I want to take the square root of is going to be 4. It's the next perfect square. So what do I want to add to 3 to get 4? Well, that would be 1. All right, 1 plus 3 is 4. Square root of 4 is 2. Make that negative. You get negative 2. All right, next square root is, next perfect square is 9. 6 plus 3 gets me to 9, so that's going to be my next input. And you could put in other numbers. You just would get decimals. It's not the end of the world, but for those of us who don't like decimals, I would recommend doing this. 2, 3, 4, 5, 6. All right, and that looks like enough points for me to get a good idea of what this graph's going to look like. All right, great. And that looks just like the picture I got in my calculator, so I know it looks good. All right, graph this over the domain -2 to 7. So they already tell me that -2 is the lowest number, but I mean, I could have done that myself because I know that x plus 2 must be greater than or equal to 0 because it's inside the radical. And we can see that x is greater than or equal to -2. So they picked the right starting point. Okay, so let's make that table. -2 is our first input. -2 plus 2 is 0, so that'll just be 0. Next, I want to get a 1 because 1's the next perfect square after 0. So I'm going to plug -1 in. -1 plus 2 is 1. Square root of 1 is 1. Next square root is 4. 2 plus 2 is 4. So 2 is my next input. And I'm going to get square root of 4 is 2. Oh, I see what I did wrong. I plotted this point wrong. It should really be up here. That's sometimes the problem. When you make tables like this, you forget which is the x and the y, so I really should, maybe for this one I'll make my table vertical. Less likely to make a mistake. And of course I'd be way less likely to make a mistake if I just used my calculator. If I just used x plus 2, well then I can see what it's supposed to look like, and I can also just go to my table and see what the next input would be. All right, next input would be 7. That would give me an output of 3. All right, because 7 plus 2 is 9 to get me to a perfect square. All right, 1, 2, 3, 4, 5, 6, 7, up to 3. That's enough for me to get a good picture of my function. Oh, and of course I just made a silly mistake. What mistake did Mr. Benak just make? Well, the domain ends at 7, so I'm going to put a closed dot right there at 7. That's the beginning and end of this function. It cannot go past this domain. That's what they told us the domain had to be. All right. Graph this function on the set of axes below, the negative square root of x plus 1. So this one is just x, so I know I'm just going to plug in perfect squares. Square root of 0 is 0, plus 1 is 1. Square root of 1, make that negative. Negative 1 plus 1 is 0. Square root of 4 is 2, make that negative. Negative 2 plus 1 is negative 1. Square root of 9 is 3, make it negative. Negative 3 plus 1 is negative 2. So it looks like they went by a little bit different scale than I would have done. That's fine. Let's say they're going up by 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. All right, so 0, 1, 1, 0, 4, negative 1, and 9, negative 2. All right, that's all for lesson 15.